Hello everyone, it's Mr. Wolfe here, and in this video I'm going to be introducing electricity or electric circuits. So this is building off of our last unit on electrostatics. So there's going to be some similarities, but there's also going to be some differences. Electrostatics, where we had usually a buildup of electrons, and electrons wanted to go from one place to another. And in this unit, it's going to be looking more at, and that usually happened in one instance with electrostatics. In this unit, it's going to be more of the continuous flow of electrons flowing through a circuit. And so we're going to start off by asking the question, what is necessary for electrons to flow in a circuit? The first one is going to be let me use a better marker here, is going to be a voltage source. There we go. So what do I mean by voltage source? It's really just a power source, all right? In a standard circuit here, I could take this battery, all right, hook it up here, all right? But notice that nothing's really happening in my model, so the next thing I need is a closed conductive loop, which just means that I need conductive material, so like this copper wire that's made out of metal, but electrons are not going to flow, or a charge is not going to flow unless it's closed. So I'm going to close the loop, and we can see that electrons are flowing through there just fine. But there's also a little bit too much electric flow with the battery, right? So I'm going to cut that, all right, no longer closed, so the electricity is not flowing. So what are some extra things that we could add to our setup, all right? Because we don't really just want electrons to flow around and waste our battery for no reason. We want to hook things up to the circuit so we could use it. One of those things could be a switch to turn things on and off. So instead of like always disconnecting my wires, all right, what I could do is, well, I will disconnect the wire right here, but I'm going to bring over this switch. Bring this up a little bit. All right. And then connect over here. Now it's still not closed, because then I could flip my switch here, all right, but then easily turn it off. So when you turn your light switch on and off at home, this is exactly what's happening. You turn it off, it breaks the circuit. You turn it on, and it completes the circuit. All right. So one thing we could add in is a switch. All right. The other thing that we could add in is a light bulb. All right. So we'll draw that in here. All right, by the way, I'm going to have my wires being continued here, so I actually might continue. I'll do it in blue. But here's my wires. All right, and we're going to do like a classic incandescent light bulb where you got this thin filament here, and it comes back. So really that's what a light bulb is, right? It's just this wire that kind of creates, there's this thinness right here. It's a very, very thin wire, sometimes made out of, the classic one was made out of tungsten. And then the bulb itself, and then just kind of the base. All right, but the wire is just flowing through it, completing that circuit. All right, so light bulb is one thing, and what we could do is we could hook that up to our setup. I'm going to disconnect over here, bring over our light bulb. All right, and let's turn on the switch. And we get it to light, right? And notice that electrons are flowing through, and as those electrons flow through, especially through this very thin wire, creates a lot of friction, it excites a lot of those atoms, and they release that energy as light. All right, so I'm going to undo the switch here. All right, so let's break down a little bit more of what's happening when we talk about current, right? We know it's this flow of electrons. Specifically, it's the flow of electric charge, all right? So it's the rate of flow of electric charge. All right, and our units are going to be coulombs per second, right? Because it is a rate, right? So just like velocities are 8 meters over second, all right? Charge, coulombs over second. That's going to be our rate for current. However, you will never see these units for current, all right? What we'll always talk about is amps instead. So amps, it's the same thing. Coulombs per second is the same things by amps, but current is always going to be measured in amps, and it's abbreviated as this A. All right, or made shorted with this A. All right, so that's what current is. All right, when we connect this, all right, we see electrons flowing through. That's a flow of charge going through our circuit. All right. Now, one thing I realized I did not draw on my model is for the two things, the power source. So my battery right here. All right, and that helps us segue perfectly into, well, what is a voltage source? So battery, that's going to be my voltage source. It provides. Let me make sure you guys can see this. So the voltage source, there we go, provides energy for charge to flow. Specifically, it does this, all right, so this goes back to electrostatics by creating a difference in electrons. So what do I mean by that? I'm going to kind of go over here. Well, in the battery, there's actually kind of like a separation here, and there's one area of the battery that's got a bunch of more electrons compared to the other side. So where do electrons want to go? Well, they'd love to go over here, but they can't, right? But once we complete this circuit, all of a sudden these electrons have a path. So they go boom and zip over to the other side exactly where they want to be, away from these electrons and going more towards that positive area right there. Right? And then as they travel through, we can harness some of that energy and create light, or maybe with a motor and some type of appliance like a blender or something like that. All right, so our units for a voltage source, or for voltage, right, is going to be volts, right, which we represent as a V. Right? And examples, we just talked about a battery, but an outlet could be another example of a voltage source, your power source. Makes sense, right? All right. So how about this term resistance? All right. So resistance is going to be the property of a conductive material to slow current down. Slow down current. All right. And our units are going to be ohms. All right, and examples could be a light bulb would be an example of a resistor. Remember how fast our electrons were whizzing through here before? And then we put on the light bulb, and now the electrons are flowing at a steady rate that doesn't cause our battery to set on fire. All right. Another thing, all right, could be a thin wire, which technically that's actually what a light bulb is. It's the wires just get really thin, at least for a classic incandescent light bulb. So just like think about on a highway, where you have a 4-lane highway, cars are going just fine, and then imagine all of a sudden that highway just went into one lane. Right? That would definitely resist the flow of traffic. Same thing happens through a wire with the flow of electrons. All right. Another example of something that provides resistance, all right, is going to be a resistor. The heck's a resistor? All right. Well, I realize, all right, that I did not necessarily draw this in my model. I guess I could hook it up. I could just draw something right here, maybe like a and just label this resistor. I could also add it to my model over here. I'm going to cut the cord here, or the wire, bring over this resistor. All right, and many times the resistor itself is just kind of a thin wire, or just made of a material that is a little bit more resistive to charge. All right. So by the way, when I press, electrons are still going to flow, but if you notice, they're even flowing at a slower rate than they were before this resistor was there. All right, so this could actually be useful to electricians when they do need to slow down current in a specific spot. They could kind of use that to bring down that flow of electrons. All right. So these are our main components of an electric circuit. All right, the voltage source, which creates current, which can be impeded by resistance, and again, the two things that we need for current to flow, that voltage source and a closed conductive loop. Now, one last thing I want to touch upon is that what we've just been looking at, all right, is just one type of current. It's called direct current, and that just means that electrons are flowing in one direction. All right, that's exactly what we see happening here. Those electrons are flowing in one direction. All right, examples of this would be, well, my computer's using direct current right now. Your iPad, your phone, appliances, smaller devices use direct current, but the electricity in your house, all right, or at Stevenson right now, is alternating current, which means that those electrons are flying back and forth, back and forth, back and forth. So something I always think is interesting is the electrons that are in the wires of your house. When they were first, like when your house was first built, those electrons are still there, all right? What's happening is when you turn on the lights, they just go back and forth really, really fast, all right? There's still that movement, all right, which could create light, or which could cause a transfer of energy, all right? But they're just going back and forth, all right? Specifically, actually 60 times every second. So they're actually flickering. It's just happening so fast that you really can't recognize it. All right, well, thanks for watching, everyone.